Okay, here's a startup for our P2 Parking Finder. This is found on our main website, CS121. Under Projects, you'll find P2 Parking Finder and its grading rubric attached. Let's take a look at the grading rubric real quick. Okay, so 25 points are for the submission, documentation, and code style. So make sure that your files are named exactly as described in the write-up. We don't have anything extra there, and that it works, it compiles. We are not using Onyx. Make sure the Java docs have your authors tag, and then we will have a README file that's attached with this project. And your code style, make sure that you have indentation and white space. Make sure you consider that, that you have correct casing, camel casing, and meaningful names for your variables, and that you use the methods from the parking spot class or the parking spot object correctly. That's worth 25 points. 75% of your grade is going to be whether or not your project will create a parking finder with the main method, that it will read in a seed and a time from a keyboard, create and print 4 parking spot objects, generate driver starting positions, calculate the print the distance from each spot to the driver, calculate and print the cost to park for the requested time, and determine which spot is closest to the driver. So those are what we're going to be working on in this project here. So Parking Finder P2 overview. Kind of went through a little bit of that with the grading rubric, but we need to write a class with a main method called Parking Finder. We will use an existing custom class called Parking Spot that is provided to us down here. We're going to use classes from the library, things such as like your scanner and whatnot. Work with numeric data, work with standard input and outputs. Okay, so first let's get started. We need to open up and have an Eclipse project named, I'm going to name it P02 Parking Finder. So file, new project. I'm going to name mine P02 Parking Finder. So there's a new project, and in here I'm going to make some new classes. So I need a new class, and that's going to be, I think it's parking spot. Parking spot. And this one is provided with us. We do not have a main method in this one, parking spot. So let's take a look at that real quick. Hopefully I got that right, parking spot.java. I did. Okay, so we're going to copy this in to our Eclipse right here and make sure we don't have any red errors going on. I'm imagining I might. Okay, so if we want to take a look at this class that is provided to us, these are going to be a lot of your methods that you're going to be using in your Parking Finder class. So we have a parking spot, we have some variables set up, street, location, X and Y, Boolean variable available or not, and cost per interval. So we have these available to us. Here's our constructor that's going to make a new parking spot that will take in the parameter street and X and Y location. We have these methods that is available, get cost per interval, set cost per interval, set available, get street, get location on X, get location Y, and a toString to print out our results at the end of the project. So we got quite a bit going on there. Let's go back to our specs. Okay, so we need another class now called Parking Finder and have a main method in that. So we have a Parking Finder class next. So next we need to go into our project, right click on that new class, and this one needs to be a Parking Finder, and it has a main method in it. So import your main method by clicking that box right there. And so we have a new project here called Parking Finder. Let's take a look at what we're supposed to do with this. Okay, we read through some of the parking spot documentation to look at what to familiarize ourselves with that particular class. So we should also test often, make sure that things are going well. You're going to have some methods from the math class such as absolute, ceiling, and minimum that we will be using. Okay, so you do not need to modify the parking spot class. You will just use it in the Parking Finder class. So this parking spot class that we created right here, don't do anything in this. This is just to be left alone and to be called upon in your Parking Finder class that we have right here. Okay, so let's kind of look through here. We have you're given a class called Parking Spot that keeps track of the details about each spot. Each spot will have a name, a street name. We should probably specify it in order that they're given like first, second, third, fourth. So that'd be the easiest way to name our streets. So when we create a street, let's maybe stick to those. We'll have an X, Y coordinate that will be placed when the spot is created. Whether or not it's available will be determined, and a cost per 10-minute interval. The default is 25 cents per 10-minute interval. The parking spot class also has the following methods for you to use. We talked about all of those already as we went through that parking spot class. Parking Finder, here's the driver class. You're going to write a class called Parking Finder. In this class, you're going to create a random starting coordinates for your car's position, so we need a random generator that generates 4 parking spot objects with random location coordinates. After your car's position is determined and the spots are created, you will calculate how much it would cost to park in each spot for a given number of time and use conditional statements to determine which spot is the closest to you. Your Parking Finder code should not duplicate any data or functionality that belongs in the parking spot objects. Make sure that you're accessing data using the parking spot methods. We do not use loops or arrays to generate this. We'll discuss that later, but please don't overcomplicate things at this time. User input. So it looks like we're going to need to have a scanner. We also need a random generator, it looks like. Let's go in there and put those in while we have that fresh in our mind here. So let's do a random generator. And a scanner. And import the associated libraries. Okay, so we have our scanner in there, new system. Okay, your program will prompt the user for the following values and read the user's input from the keyboard. A long value to seed your random number generator. The seed values read from the keyboard should be used to initialize your random number generator. Look at the different constructors available in the random class to recall how seed values are used. Okay, so we need to have a long value for a long seed value. So let's make that a variable. Just start off with it like that. We don't have it sets anything quite yet. We'll need to have an int value for the amount of time needed in minutes, so then we can do int time. You got a couple of those ready to go. You can use the next long method of the scanner class to read the seed of the random number generator and the next int method to read the parking time. Okay, so we could have them enter in a seed, and we could then put that into a random generator for that seed. So that should be that should be something we need to do so that they can test the reliability of their project. Okay, so let's set up that seed value next. So we have our scanner, and we're going to be scanning in a seed value that will go into the random number generator, and then with a seed value, basically the randomness is gone. It has the same results every single time when we do that same seed. So let's try that here. So we're going to ask the user for a seed value. And then when they type that in, we're going to say seed is going to equal to our scan dot next long, because the seed is a long. And we have our random generator, but now we're going to put that seed value into our random number generator. So I'm going to move this down to here. Now that I have a seed value available, I'm going to put it right here in the parameters seed. That way I will be able to reproduce my results. And if we want to change that, that's perfectly fine. We can come back and do that later. But we have a lot to do. We're generating the car's location, so we need to think about that in the range of 0 to 99. So initialize 2 random integers, car x and car y, in the range of 0 to 99. inclusive to designate the driver's starting position. Use your seeded random object to generate the random coordinates. These must be generated before your random parking spots in order for your output to match the sample output. And then the position of the vehicle should prompt out, something like that. So let's try to get our first parking spot. Determined, and it's just going to be so we're generating the car's random location, random parking spots, distance. Okay. All right, so the next thing we're going to be doing is we're going to create a parking spot object. So we are going to kind of refer back to this constructor here. So we will have to make sure that we get the parameters in street, X, and Y. So that's where we're going to get our random X and Y location. So let's create one of those. And right here. So I'm going to go with, it's a parking spot. I think I'm just going to remember that. All right. I need to make sure I name it exactly the same so it refers to that class. Parking spot, I'm going to say spot 1 for the new. And we have, remember, it suggested we do things like first street, but it's going to be in quotations because that is a string. And then we have a X and Y location. So they said it needed to be between 0 and 99. So I'm going to do a random dot next int between and have its values of 100 because that'll be 0 through 99. I'm going to do that for X and Y. So there should be able to create our first parking spot object. Let's just see if I were to see what happens if I print out spot 1 right now. I don't know if we're going to get anything. Enter a seed value. Okay, so by me entering a seed value 1, 2, 3, 4, 5, we have an X location of 51 and a Y location at 80. I'm going to try it again. So with the same seed, we get the same location X and Y. With a different seed value, though, I get as you can see, my X and Y have changed. So I'm able to reproduce that based upon that seed value. If I keep the same seed, the locations are in the same spot. Right now, it looks like it's available. It has the street name is First Street, and it's 25 cents per interval. Okay, good. So we're cruising. You'll need to make sure you create 4 spots there, because there'll be 4 vehicles. But now we at least know that the position of the vehicle is coming out correctly. So create 4 parking spot objects with those random coordinates. Then we also need to make sure we prompt the user for how long it's going to be parking, how long they're going to be parking their car at that particular spot. So that'll be the next piece in here after you get your parking spots created. We're going to ask how long you're going to park there. So we are needing to say to the user, enter in parking time in minutes. Okay. So then they're going to ask that, and I'm going to say time will then be stored into that scan dot next int. So now time is now stored into there. We need to then do some conditional statements here to figure out if they entered in anything more than 0. I would imagine we need to figure out how much it's going to cost them. So that's going to be something you'll need to figure out there as well, as to figure out time. So we have ourselves a, we don't have any minutes yet, so we'll need to create a variable called minutes. So we can do that up here. And let's make that a double. Let's make it double minutes. Like that. So down here, after we have our time entered in, we might want to say if time is greater than 0, so they actually entered something in. Then let's say we could say how many minutes that's going to be. So these are entering in times. This is another thing you'll need to figure out here. Thinking about this carefully, the specs say that they're 10-minute intervals for these parking spots. So if a user types in 30 minutes, that's only going to be 3 intervals that they're going to be charged for. And we do want the first 2 parking spots to have the default cost per interval, and the last 2 spots to be 30 cents per 10-minute interval. So you got to think a little about how you're going to get that. But if a user enters in 30 minutes, that is 3 10-minute intervals, and each interval is costing a certain amount of money. So it would not be like 30 cents for 30 minutes. It would be 30 cents per 10-minute interval. If it's a 30-minute parking time, that's 3 intervals, so it'd be 30 times 3. That would be how much it would cost you to park in that spot. So you got to think about how you're going to do that as well. Make sure that you're considering that these are in intervals. So that would be there. I would say minutes, then it's going to be something like minutes is going to be equal to something that you would figure out how to get your minutes next. To do would be figure out minutes. We need to we will need to do a parking spot distance. So we need the distance that is going to be from your X location minus your car's X location plus the Y location minus the car's Y location. That's how we're going to figure distance. So next I'm going to do int car X is going to be some random dot next int, and 0 through 99 is there as well. This will give me now, so if I'm going to be able to get my car's X and Y location, and I have my spots location up here, I can then figure out the distance between those two. So I have a method called spot. I have lots of methods when I type a parking spot, or actually type in spot 1 dot. I will be able to figure out the methods that come with my parking spot. Spot class, parking finder class that's associated with it. I mean the parking spot class that's associated with this. So I've got my X and Y. I'm going to do one distance for you. Int distance 1, I just named it distance 1, is equal to, now we had lots of different ways of finding the difference between numbers, and the one I liked the best was math.abs, or absolute value. That it works really well for this because it's for distance, and we're looking at distances here, so this works really well. Math.abs, and in here I'm going to do spot 1 dot. Now you can start to see all the methods that I'm getting. So I need to have, we're finding distances, so these are going to be locations, and we're dealing first with our X location, so I need to get location X. Now I have that location, and I'm going to minus that from my location I just generated here previously. So now then that's going to be the difference in my X coordinates, and I need to add to that the difference in my Y coordinates as well. And that will be the distance for distance 1, absolutely. So 1, 2, 3. Okay, so here we have our distance 1. And that's going to be the differences between spot X and car X plus spot Y minus car Y. You'll need to find the distances for all 4 of those. So we're now getting a few things printed off here. Let's try if we can get distance. Let's see if we can do that. Enter seed value. 1, 2, 3, 4, 5. Enter parking time in minutes, or something like that. And so actually we don't have anything printed. Oh, right here, I can just this. Okay, so it's 62 is the distance to parking spot, the distance from where we are to where car X and Y is. So, from where we are car X and Y, and we need to look at our spots, location of where we're going to park. So it's 62 away. So you'll find differences between these. You'll see a distance 1, 2, 3, 4, and you'll need to find the closest one. Okay, once you get through all 4 of those, we need to set the cost of the spots up. And remember that 1 and 2 were default, which came up really easy. Cost per interval was 0.25. It did say, though, that spots 3 and 4 were at 30 cents per interval. So we need to do a spot 3 dot. Well, I don't have a spot 3 yet. I have spot 1 dot. Now I could set cost per interval here, but I don't need to because spot 1 and 2 are fine. When you get spots 3 and 4, you will need to set there. So it would look spot 3 dot set charge for a certain amount, like 0.30. Now I don't have a spot 3, so that doesn't work for me at this time yet. And then I need to get the cost per each. So then I would say, I have a cost. I don't have a cost 1 yet. I'm creating that right now. Equals spot 1 dot get. This is going to be get charge, get cost per interval times minutes. But I don't have my minutes done yet, which was right. We needed to set that up here. And then after you have that set up, you need to, after you get all those done, you'll need to print out information. And so that would just simply be printing out spot. It would look kind of like this. So I would say parking spot 1 plus spot 1. And I can kind of make it look nice too by doing one of these things. And I can, inside here, put some a tab. That way it shifts it over in the print line. Distance equal to plus distance 1 plus and we will need to have a format here too as well. I forgot about that. So at the very beginning, we probably need to format our stuff up. So we're up in the beginning. Let's do a format. And this would be for currency. So you need to look that up. And that way, when we come down here, it'll be formatted so that it prints that cost out with a $sign, and we kind of know what that looks like. But that, I would say, if you create maybe you have a number format, and it's just format. So it might be format dot format. Or I would say maybe let's just do number format. So up here it would be to do number format. Number format equals whatever you need to do to get your number format and get currency. And then I could use that NF down here. Number format, dot format. And that would be on, I say, cost 1. Because this is all associated with spot 1. And then you need to compare the distances. So from here, then you'll need to determine which spots are closest and the cost. Now I like the math.min method. Personally, I like that min method because then you have two numbers, and it would just simply find the minimum value of those two. And then you can compare those to, you can compare, maybe you might want to say you want to have distance 3 compared to the distances between 2 and 4. And maybe say if distance 1 is less than that, then you probably would come out with it being distance 1. If distance 2 is less than maybe math.min of distance 3 and math.min of distance 1 and 4, and that could work too. Okay, so there's kind of a quick run through on getting you started as far as what that might look like. Let's say we probably want to give at this point in time, we've got some issues here. This R does not need to be there, and there's some issues in that line, so I'm going to do that. And this, because we need to get that min done. So now I should have, and you do want to give the position of your vehicle before you say the other spot's distances. So I would say position of vehicle X equals probably with space in there, make it look nice. And then so that'll tell us where we are at, and then we can get the other spot. So if this, so I'd say if distance 1 is less than math.min of distance 3, and then in here I'm going to say math.min of distance 1, distance 4. Okay, so that is going to say first we're going to go in here, we're having the distance between 1 and 4, and then we're going to find the minimum of those two, and then find the minimum of 3 versus those two, and then if 1 is less than all that, then it's going to be spot 1. So then I would say was weird. Let's say and you may want to clean that up a little bit to see if that looks right. You know, you're going to want to make sure that it doesn't look unprofessional. That's kind of an idea of how you're going to do your parking finder project. So that's a good starter point, and we'll pick up from there at another point down the road.